This is my Volkswagen Passat. I converted it 10 years ago to make it electric, and after 90,000 miles, I wanted to give you a quick tour and show you all the modifications I made to make that happen. I bought this Passat on Craigslist in 2008. It had a seized cam, so I got it for a cheap price, and I bought it with the intention of converting it to electric. It was an automatic transmission, and in the process of converting it to electric, I converted it to a manual transmission. It's a little tattered these days. It hasn't received much TLC, but I haven't had to do anything to it really. Haven't had to change any brake pads. Haven't had to do any oil changes or spark plugs or tune-ups. I change the transmission fluid maybe every 20,000 miles, just because I'm running such high revs on it. I can show you how I charge the car. I have a 240 volt circuit here going through a spot disconnect, and I have a timer installed so that the car will only charge after midnight when electricity is cheaper. I also have a 1772 converter so I can use the public charging stations. And I just have a simple twist lock plug here. And when I plug it in, I have a dome light so that people know if it's charging or not. And I can show you inside the trunk. So this is the inverter that I built. These are the two battery cables, and I'm running 330 volts at 300 amps. So about 90 kilowatts. These are the three-phase leads going to the motor. And there's some current transducers for feedback. And I'm also using encoder feedback with the VFD. Up here I have some contactors. That's the main contactor and a contactor for the heater. And I have a pre-charge contactor on the back side that you can't see. And that's my pre-charge resistor. These circuit boards are used for the battery management system. It basically makes sure all the cells are within a safe voltage range. And all of these fuses are used to connect the cells to the BMS. The fusing there is for safety in case the wire gets shorted by accident. It also allows me to disconnect a battery from the BMS and charge it manually if I need to top off one cell. This is my charger. The batteries are fully charged right now, so it's not pulling much current, but I can pull, I think, 23 amps at 240 volts. And this is a power supply that connects to the AC input of the car, and that's used to run the cooling fans. So the 24 volt fans will run whether the car is plugged into 110 or 240. Under here is my DC-DC converter. That converts the pack voltage, which is 330 volts, down to 12 volts to charge the lead acid 12 volt battery. It normally puts out 12 volts, and with the ignition on, it outputs 13.5, so it behaves like my alternator. This is a cooling fan. I have it unplugged just for the video. This is drawing cold air from the dead body vent at the bottom. And this is that's the inverter that runs the air conditioner. And this fan blows cold air to the back of the charger. The hot air comes out of the charger here. And when this temperature switch clicks on, these fans will exhaust the hot air from the trunk out behind the license plate. And because the trunk is sealed, if I didn't have ventilation, the battery charger would quickly overheat and kind of throttle back charging. So, especially here in California. Underneath here I have more cells. And I also have more cells under where the gas tank used to be. I had custom springs wound to support the extra 500 pounds of weight that the batteries added to the rear. Behind this rear seat are more cells. This is kind of the brains of the BMS system. If the BMS detects any problem with any of the cell battery voltages, the buzzer will sound if I'm driving, or the charger will disconnect using that solid state relay. And this is a current sensing switch. When my charging current drops below 1 amp, then it'll turn that light from orange to green to let people know that it's okay to unplug my car. Here's a look under the hood. It's a little bit grungier than it was 10 years ago. These are more battery management boards. These are individual boards on each cell as opposed to what I had in the rear, which was one circuit board that connected to many cells. The circuit's the same, it's just a different package. You can see the series healthy signal. So if one battery is out of range, this series circuit will open and shut the charger off or sound the buzzer. That's my air conditioning compressor, which is a DC brushless motor. You can kind of see the end of the motor down there with the cooling lines going to it. And this is my 12-volt power steering pump. It's a hydraulic pump. And this is a shunt that makes the ammeter work. Under here is the original 12-volt lead-acid battery. I kept the 12-volt battery just in case the ABS pump kicked on or the airbags might need a lot of current to operate. So this is just there to handle some of the inrush current, especially with power steering. Under this panel is my vacuum pump reservoir. I have a pressure switch that runs the pump, and I have a delay off timer relay so that the pump will continue to run even after the pressure switch has met its pressure. This just prevents short cycling of the pump. And that is a circuit breaker that connects the DC-DC converter to the lead-acid battery. Just lets me disconnect it if I need to. And on this side I have the contactor that runs my power steering pump. And way back there is where the fresh air intake filter used to be. And I've capped that off, and that's where I've placed my electric heater core. The car still starts like a normal car. Just turn the key. Wait for the pre-charge resistor to charge the inverter, and then I click the drive into start. And you can see on the bottom left where I've changed the clock into a digital voltmeter. And when I'm driving, it shows the current voltage, and V low is the lowest voltage recorded over the last 30 seconds. So that gives me an idea of how low the state of charge is on the battery if the voltage sags a lot under load. I'm using an Arduino to run the 2-line LCD and sweep the tachometer needle, which is run by a stepper motor. I have an ammeter that shows when I'm driving how much current I'm pulling or generating when I'm braking. This is my battery meter. Right now it's showing I'm pulling about 0.8 amps, and I've consumed 2.7 amp hours. And my batteries are 100 amp hours, and I get about 1 amp hour per mile. So this gives me a good indication of how much range I have left. And over here is the switch for my heater. So on low, it pulls about 3 amps. And underneath that is just a temperature controller that clicks the heater on and off at a preset temperature, so I don't normally have to mess with it. And this is for the seat cushion that I'm on. It's a heated and cooled seat cushion. And I also have an air conditioner. You'll hear it click on here in a second. The air conditioner runs at low speed just to get the refrigerant circulating. and then I can run it at a faster speed using the keypad on my controller. You'll hear it click into high gear here in a second. And I can adjust the speed. So if I want more or less cooling, I can control the compressor speed. Well, that wraps it up for all the modifications that I've made to the car. Since the last video I showed of the car running, I've made so many modifications, minor incremental improvements to the way it drives, and I've never made another video showing how well it rides, so today I'll give you a quick test drive around the block to kind of show off. The hardest part was getting smooth torque from 0 speed, and I don't know if you can tell now, but it's really smooth. And still quite peppy. I'm always impressed driving this car, how much torque it has off the line, even compared to the sports cars that I own. All that torque is right there as soon as you hit the pedal. The brakes are really responsive as well because the regen assists the regular brakes, so it has kind of super stopping power, like it had a big brake kit. It pulls about 30 kilowatts of regen braking. One of the tests I always did in trying to tune the motor at low speeds was going up my driveway. You can see here, even if I'm rolling back, I can give it a little throttle and it'll climb back up the driveway. That's something I could never do without the encoder installed. I'll show you how I shift. I'm in second gear now. I'll put it in neutral and this light will turn on when it's time to shift. And that tells me the motor's RPM is matched for the next gear. If you're interested in more technical details, I'll have another video posted showing how I built the drive inverter and how I adapted the motor to the transmission. You can check that out on my webpage. I'll post a link at the end of the video. And thanks for watching.